we are not always looking at the continuous variables. And to make the comparison, whether the mean or means are statistically different from each other or some specified value. Sometimes our interest is to look at the categorical variable, where it could be binary response or it could be multinomial response. In this module, we will learn testing of hypothesis of single proportion, where our interest is to looking at the binary variable. Binary variables are the variables that have two possible outcomes. It could be success or failure. Some examples include that if a person is a current smoker and their response is yes or no, or for the gender, we can look at the binary categories as male or female, or survival 5+ years. If a person survived more than 5 years, yes or no, if a person didn't, or case or no case, yes or no. So this kind of scenario where we have two possible outcomes, we call such variables as binary variables. When our interest is looking at binary variables, they follow the binomial probability distribution, and we get the binomial proportions. Hence, we start by calculating sample proportion p hat, where p hat is a sample proportion which is equals to x over n, where x is the number of successes. If a simple random sample of 57 adults identifies 17 smokers, therefore the sample proportion will be p hat equals x over n, where x is the number of successes, that's 17, and 57 is the n. Finding this ratio, it is 0.2982, which is 29.82%. Our interest is to look at that whether this sample information can be generalized to the population. And if our goal is to generalize our sample results to the population, we carry out statistical inference. And here, our interest is to look at the inference about the proportion, where we have a huge population, and the result that we get out of the population is a parameter. And we always want to estimate that. Hence, but we cannot study the population, so we rely on the sample, and we study a sample, get the data, and when we study a sample data, we get a result that is called statistic. And we use the statistics to infer the population parameter. So here, p hat is the point estimator of parameter p, which can also be denoted by pi. So pi is the population parameter for proportion, where p hat is a sample statistic for the proportion from the sample. Hence, the sampling distribution of p hat is approximately normal with mean p and standard deviation p1 minus p divided by n square root. So the z statistics has approximately the standard normal distribution when h naught is true, and the p values therefore comes from the standard normal distribution. Here, since we are interested in only looking at the one sample at a time, so we will run one sample z test for the proportion. Let's choose a simple random sample of size n from a large population that contains an unknown proportion p of successes. So to test the hypothesis h naught p is equals to p naught, we compute the z statistic, which is our test statistics to carry out one sample z test for a proportion. Z equals p hat minus p divided by p naught into 1 minus p naught over n, where p naught is the proportion calculated in the sample. So our interest is to find the p value by calculating the probability of getting a z statistics. This is larger in the direction specified by the alternative hypothesis, HA. So for the sign, for the null hypothesis, for the equality of the proportion to the stated null value, P naught, alternative hypothesis could be P greater than P naught, which will make our test to be single-tailed, and it will be right-tailed test. Or alternative hypothesis could be that P is less than P naught, which will make our one-sided test to be left-tailed test. And for the null hypothesis, when P equals to P naught, our alternative hypothesis can be two-sided when P is not equals to P naught stated. In that case, we'll work with two-sided test where we will use both right tail and left tail. So the p-value in a one-sided test is the area in one tail of the standard normal distribution and the tail specified by the alternative hypothesis. So in a two-sided test, the alternative hypothesis has the form HAP not equals to P naught. So the p-value of such a test is the probability of getting a sample proportion as far as or farther from P naught in either direction than the observed value of P hat. As a result, you have to find the area in both tails of a standard normal distribution to get the p-value. So let's take an example where we have collected data on a sample of 301 Hispanic women living in San Antonio, Texas. One variable of interest was the percentage of subjects with impaired fasting glucose, which is denoted by IFG. In the study, 24 women were classified in the IFG stage. It was known that the proportion of IFG among Hispanic women is 6.3%. So our question of interest is there a sufficient evidence to indicate that the population of Hispanic women in San Antonio has a prevalence of IFG higher than 6.3%? First of all, we'll look at our given information, and the given information states that the data are obtained from the responses of 301 individuals, of which 25 possess the characteristics of interest. Hence, the p hat is 24 by 301, which is equals to 0.080. Using this information, we'll test the assumption that whether the study subjects may be treated as a simple random sample from a population of similar subjects. And the second assumption states that the sampling distribution of p hat is approximately normally distributed in accordance with the central limit theorem. Since the sample size is sufficiently large, we can assume that this assumption is satisfied. Hence, to test the hypothesis that if this proportion is larger than 0.063, we state our null and alternative hypothesis. Our null hypothesis states that the proportion is less than 0.063 against the alternative hypothesis that the proportion is greater than 0.063. Here, this P represents the population proportion. We want to test this hypothesis at 5% level of significance using usual z-test for the testing of single proportion. Since the p-value as calculated at step 4 equals 0.1131, which is not less than alpha 0.05, hence we fail to reject the null hypothesis and conclude that the population of Hispanic women in San Antonio has a prevalence of IFG not statistically significantly higher than 6.3%.